If you want to know how much air is going through a coil that's being unaffected by the cooling process, then you can use this coil bypass factor equation. So you just take the leaving air dry bulb minus the effective coil temperature divided by the entering air dry bulb minus the effective coil temperature. So in this example, if we have a 60-degree dry bulb supply and the return air is 80-degree dry bulb, then we need to know what our effective coil temperature is. To get this effective coil temperature, and it's the same thing as apparatus dew point, is you can plot that on the psychrometric chart, because you plot your return air state point, you also plot your supply air state point, you draw a line through the two, and you go straight to the saturation curve with that line. Once you get to there, that's your apparatus dew point. So you can do it with a psychrometric chart, or you can measure the temperature of the coil. So you enter those into the formula. So if you take 60 degrees minus 47.5, and you take the 80 minus 47.5, you end up with 12.5 divided by 32.5. So 0.384, or 38% of the air moving across this particular coil in this example is being unaffected. So if you increase your airflow, you're going to have more bypass factor. If you decrease your airflow, then you're going to have less of a bypass factor. So in situations like a computer room, you end up with, they don't want a ton of dehumidification, so they'll have purposely higher airflows than, say, at your house, where you want more contact with the coil, more time to dehumidify that conditioned air.